let's do a Lewis structure for one that's a little bit more challenging. One of the things that students tend to find more challenging would be polyatomic ions. They've got charges, they tend to be a little bigger, all those kinds of things. So let's do one for phosphate. Hopefully you already know, but if you don't, it's on the back of your periodic chart. Right, phosphate would be PO4 with a -3 charge. So of course step one is to figure out our valence electrons. Right, our valence electrons for this. We're going to need to know the valence electrons for phosphorus, our valence electrons for oxygen, and then deal with this charge issue too. Right, there are 4 oxygens here. So if we jump over to our periodic chart, on our periodic chart, our phosphorus is right here in column 5, of course, right? So our phosphorus has 5 valence electrons. Our oxygen has 6 valence electrons, and of course there's 4 of those to deal with. So we look at those two. We have our 5 from phosphorus, our 24 from our 4 oxygens, and then this 3, right? So if we do those two, that's 29. And then if it's got a -3 charge, right? Electrons are negative. So if I have 3 extra negatives, that means I have 3 extra electrons. So that's a bonus 3 electrons. Try not to memorize things being backwards. That tends to just confuse us later on. So, right, so for my PO4, with a -3 charge, I'm going to get a total of 32 electrons. Second step is to figure out who goes in the middle. Phosphorus is going to be the one who goes in the middle. And again, I'm going to guess at a skeletal structure of doing something like this. And then let's just see where we're at. The next thing that we would do is just bond everybody to the central atom one time. It is very unlikely that you make chains and things like that, or ring structures with anything other than carbon. Those are the only things that ever really tend to do that. So if I just bond everybody once here, that's going to make phosphorus happy, but none of the oxygens, and I still have a lot more electrons to deal with. So looking at one like this, I've got 2, 4, 6, 8 electrons dealt with so far. The first ones or the next places to go with my electrons would be these outside atoms. Our most electronegative atoms go on the outside. They get their electrons next. So if I've already got 8 put out, we go 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So there's all 32 electrons. I don't see any need to double bond anybody or anything here, right? So we have to put brackets around it in a -3. Everybody has a share in 8 valence electrons, right? So we are perfectly good just like that. So that one's kind of intimidating, but it's actually a pretty simple structure once you get to it, right? Doing another one, nitrate. Nitrate would be NO3 with a -1 charge. Nitrogen would go in the middle. Again, we need to figure out our valence electrons, but we'll just go ahead and guess at a skeletal structure of something like this. What it comes down to a lot of times is just, does somebody need a double bond or anything like that with these basic things that we tend to deal with. So our valence electrons, nitrogen would have 5. And then, of course, again, oxygen would have 6 times 3. We get pretty used to oxygen because it just happens to be in a lot of things. Right, so we have our 5 from here, our 18 from here, and our 5 plus our 18 is 23. That -1 charge is going to change us. That's going to change us from being 23 to being 24 because we added 1 extra electron because electrons are negative, and we had a negative charge. So I have 24 electrons to put out now. I'm not going to put any more electrons out on the central atom until I get all of them on the outside. So we go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. All right, so we've got all of our electrons put out now. There is one issue right now. And I do need to bracket it and put a -1, but that's not really my main problem. My main problem is my nitrogen. My nitrogen only has 6 electrons. I don't have any more electrons to put out. So the rule always, if I need more electrons to put out, or I need more electrons on one of my central atoms, but I don't have any more electrons to put out, is to just move some. So I'm going to pick one of these oxygens and get rid of their electrons there and move them in here. All right, so now this oxygen has 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. Everybody's got 8, and I'm still showing my 24. I kind of like to redraw them after that because that's a little messy right there, so I'll put it in brackets. That way nobody's confused, whoops, about what I'm showing, and then I go and put a dot on it like that. That's very helpful. Need some white out. writing with a Sharpie, and we can't show that. Yeah, a little bit of big scratch out there. That's not an electron right there. If it was on a test, I'd certainly want to rewrite it. I don't have a Sharpie eraser though, so